Ever wonder what secrets lie beyond our own solar system? Well, sometimes those secrets come to visit us. Let's talk about a truly special guest, an interstellar comet named 3IATLAS. This isn't just any comet. It's a traveler from a distant star system, offering us a rare glimpse into the universe far, far away. When astronomers first spotted 3IATLAS, they noticed something incredibly bizarre. Not only did it have a regular tail pointing away from the sun, but it also sported a strange sun-facing anti-tail. As they watched closer, they saw something even more mind-blowing. The jets of gas and dust shooting out from the comet weren't steady. They were oscillating, wobbling back and forth like a sprinkler. This was a cosmic light show nobody had ever seen before from an interstellar visitor. So what was causing this celestial dance? The answer lies in the comet's spin. By carefully tracking the rhythm of these wobbling jets, scientists were able to calculate how fast the comet's core, or nucleus, was rotating. They found it was spinning surprisingly fast, completing a full turn every 15.5 hours. Think about that, a giant icy rock tumbling through space, all while putting on this spectacular display millions of miles from home. This discovery is a huge deal. It is the very first time we've ever been able to measure the rotation of an interstellar comet's nucleus. It gives us a brand new piece of the puzzle, a benchmark we can use to compare these alien objects with the comets from our own solar system. Are they similar? Are they wildly different? By studying these pristine messengers, we can learn more about how planetary systems, including our own, are born and evolve. So, the next time you look up at the night sky, remember that it's not just our solar system up there. There are travelers like 3IATLAS carrying stories from distant stars right to our cosmic doorstep. The third object of its type ever confirmed to visit our system of solar. Observix details revealed the presence of oscillating gas jets emanating from its rare anti-tail, a structure that points in the direction of Sol. S phenomenon provided crucial data to calculate the rotation speed of its nucleus. The analyses, conducted between July and September 2025, as the comet moved away from its closest approach to Sol, showed that the jets pulsed in a regular cycle. ESA activity allowed scientists to determine that the nucleus of 3IATLAS completes a revolution in itself in approximately 15 hours and 30 minutes, a rate considerably faster than previous estimates suggested. The discovery not only deepens knowledge about this visitor from another star system, but also establishes a new point of comparison with comets native to our own system of solar. Jet dynamics and accelerated rotation offer valuable clues about the composition and physics of celestial bodies formed in distant stellar environments. The physics behind the anti-tail. Unlike dust and ion tails, which are pushed away from the Sol by solar radiation and wind, the anti-tail is a more complex and rare optical phenomenon. Ella forms from larger dust particles, millimeters in diameter, that are too heavy to be significantly affected by solar radiation pressure. ESA's particles tend to remain in the comet's orbital plane, slowly spreading out along its trajectory. Quando the Terra intersects this orbital plane, the observer's perspective makes this dust trail appear to point in the direction of, in the case of 3IATLAS. This structure reached an impressive length of nearly 1 million kilometers at its peak, providing a natural laboratory for studying the ejection of cometary material. Observation details at Tenerife. To capture this behavior, an intensive 37-night observation campaign was carried out. Astronomers used Telescopio Gamio of Deutsche Metros, located in the Observatorio Tide in Tenerife, in Islas Canarias. The quality of the data allowed us to clearly isolate the phenomenon, especially during 7 specific nights in August 2025. Images processed with advanced techniques highlighted a narrow, well-defined jet emerging from the comet's coma, the cloud of gas and dust that surrounds the nucleus. The precession movement of the jet, similar to the wobble of a top, worked like a cosmic clock, allowing scientists to precisely measure the cycle of its activity, and consequently, the rotation of the central body. The results, already submitted for peer review, represent a milestone in the study of interstellar objects. accelerated rotation, and the mystery of the nucleus. Analysis of the jet pattern revealed an oscillation period of approximately 7 hours and 45 minutes. Como the jets are activated when a specific region of the nucleus is heated by the. This speed is significantly greater than that observed in many systems of solar comets, and suggests that 3IATLAS may have undergone rotational acceleration during its long journey through space or in previous passes by other stars. The core, estimated to be between a few hundred meters and a few kilometers in size, demonstrated remarkable structural integrity. L withstood tidal forces and intense heating during its passage close to Sol, a feat that provides clues about its internal cohesion and material composition, what makes 3IATLAS unique. The first, 1IATLAS, was an elongated rocky object that exhibited no visible cometary activity, leaving scientists with a mystery about its nature. The second, 2I Borisov, behaved much more like the comets we know, displaying a well-defined coma and tail. Although its chemical composition showed some peculiarities, such as a high concentration of carbon monoxide, 3IATLAS positions itself as a fascinating intermediary. L displays clear cometary activity, but with unique features, such as oscillating jets and a prominent anti-tail. ESA diversity among interstellar visitors suggests that the formation of planetary systems elsewhere in the galaxy may be an incredibly varied process. These differences are key to enriching theoretical models about how planetesimals, the building blocks of planets, form and evolve in different cosmic environments. The interstellar visitor's journey. The comet was discovered in July 2025 by the Astronomical Survey System ATLAS, Asteroid Terrestrial Impact, Last Alert System located at Chile. SWA hyperbolic trajectory with an excessive speed to be gravitationally bound to Sol quickly confirmed its extrasolar origin. The object reached perihelion, its point of closest approach to Sol, in October 2025, passing within the orbit of Mars. SWA's closest approach to Terra occurred on December 19, 2025, at a safe distance of about 270 million kilometers, before beginning its long journey back into interstellar space. Implications for future research. The detailed study of 3IATLAS jets provides valuable data that will help refine models of ice sublimation and dust ejection from primordial bodies. Comprehending these mechanisms in an object from another planetary system is crucial for comparative planetary science, allowing us to test the universality of the physical laws that govern the formation and evolution of comets.